SSN has a feature called on-chip compare. When you enable that feature, our tool automatically detects identical cores and then broadcasts data to them. What is important about this feature is that it really doesn't matter how many cores you test. If you have 1 core, 10 cores, or 100 cores, you're going to have exactly the same test time and exactly the same data volume. This feature also is diagnosis friendly, so the patterns that you have generated with on-chip compare can be used on the tester to gather diagnostic data for further diagnosis. What is also important is that you can use this feature and you can have multiple groups of identical cores together with groups of non-identical cores, and our tool will make sure that everything works and you can apply those patterns on the tester directly. SSN was designed with test time reduction in mind. I guess the first important feature of that solution in general is that it's very physical implementation friendly, and it can be used for tile designs, multi-die designs. What happens with SSN is that every scan streaming node SSH generates local shift clock and control signals, and this helps with time enclosure, and as a result the clocks can be faster, the control signals can be faster. So just by this friendliness of physical implementation, it can reduce test time. The other feature is on-chip compare. When you have multiple identical cores, you can enable on-chip compare, broadcast the data to those identical cores. As a result, test time is going to be reduced in such configurations. And the last feature is called throttling. Throttling is designed to control how much data is delivered to every core to minimize padding. And the tool works with the hardware capabilities and the software capabilities to figure out the best programming. The tool has a sophisticated algorithm that can limit the number of bits that are sent to every SSH. And as a result, the packet that we send through the network is smaller, and a smaller packet means better test time. SSN was originally designed to deliver scan data, but since the original release, we created some functionalities that reuse the bus to deliver non-scan data. The first one is called high bandwidth IJTAG. This functionality uses the SSN bus as a multi-lane highway that delivers the data to local IJTAG subnetworks. Those subnetworks generate their own TCK and control signals. This solution is best used if you have multiple instruments that require relatively small data, because you can run and distribute the data into all of those instruments in parallel. The other solution is called GDS, Generic Data Streamer. This solution is an enhancement to the the released SSH streaming scan host. When this feature is enabled, the SSH has a generic interface that can be connected to any instrument. The solution is generally protocol agnostic, so you can drive any instrument. In this solution, the full bandwidth of the bus is diverted into a limited number of instances. So you can imagine if you want to load a memory or read from a memory, or you want to load the firmware, you would use a solution like that by sending the full bandwidth of the bus just to deliver relatively big amounts of data.